Mm. Hello everyone. Welcome to this Starknet contract development and deployment stream. Development and deployment. So what we are going to do in this stream is learn. So objectives of this is first of all learn how to write a simple contract, simple Starknet contract. Learn how to deploy this contract, how to deploy, how to declare the contract to Starknet. Learn how to deploy the contract on locally with Katana. Learn how to deploy, how to interact with the contract, and how to deploy a contract on Starknet testnet. Okay, so we are going to do all of these things. Okay, so the repo that we are going to use for deploying and development is this let me just do ls, and we have this Cairo smart contracts repo. Cairo smarts contracts. Let me see if there is anything. So there is some changes, so let me just post this. Readme changes. Okay, now we are going to create a new branch. Let's say examples. Say maybe we just like storage contract. Okay, let's open this, and now then we are going to go with on the let me just manage this thing. Maybe we need a web browser here. Yes, that's fine. So let's go to, we are not going to use Foundry, so let's go to Cairo book. So we will start by reading this this guide, Starknet smart contracts, and then making our notes and basically following the Starknet book and then following the process. Okay, so Starknet smart contracts. All through the previous sections, we have mostly written programs with a main entry point. In the coming sections, you will learn how to write and deploy smart contracts. One of the examples of the Cairo language is to write smart contracts for the Starknet network. Starknet is a permissionless network that leverages JK Stark's technology for scalability. We have already talked about Starks versus Snarks in our previous streams. So if you haven't watched that, feel free to look at them. So as a layer 2 scalability solution for Ethereum, Starknet's goal is to offer fast, secure, and low-cost transactions. It functions as a validity rollup, commonly known as a zero-knowledge rollup. Again, we have talked about the validity rollup versus optimistic rollup in our previous streams. So validity rollups is basically something which uses this technology called zero knowledge, where you are able to prove to somebody that you have this information, and that verifier is able to verify that this information is correct, and without you actually revealing anything about the information. Yeah, so it is built on top of Cairo language and the Starknet VM. So Starknet contracts, in simple words, are programs that can run on the Starknet VM. Since they run on the VM, they have access to Starknet's persistent state, can alter or modify variables in Starknet states, communicate with other contracts, and interact seamlessly with the underlying L1. Okay. Starknet contracts are denoted by the contract attribute. We will dive deeper into this in the next sections. So if you want to learn more about the Starknet network itself, its architecture, and the tooling available, you should read the Starknet book. Again, the amazing resource Starknet book. This section will focus on the Starknet writing contracts in the Cairo. Okay, we have already done the setup. So let's go to introduction to smart contracts. So this chapter will guide you a high level introduction to what smart contracts are, what are they used for, and why would blockchain developers use Cairo and Starknet. If you are already familiar with blockchain programming, feel free to skip this chapter. The last part might be interesting though. So smart contracts. Smart contracts gained popularity and became more widespread with the birth of Ethereum. Smart contracts are essentially programs deployed on a blockchain. The term smart contracts is somewhat misleading as they are neither smart nor contracts, but rather code and instructions that are executed based on specific inputs. So the term smart contract was introduced by guy named Nick Szabo in his famous paper on the smart contract, where this particular code which is visible to everybody and which is sort of immutable. It code works as a sort of a mediator between two parties, or basically code works as a law, so or as a rule. So that's basically the whole idea of smart contracts. Once deployed, users can interact with the smart contracts by initiating blockchain transactions containing execution data, which function to call and with what input. Smart contracts can modify and read the storage of the underlying blockchain, and a smart contract has its own address and is considered a blockchain account, meaning it can hold tokens. Okay. The programming language used to write smart contracts varies depending on the blockchain. For example, on Ethereum and the EVM compatible ecosystem, the most commonly used language is Solidity, while on Starknet it is Cairo. The way the code is compiled also differs based on the blockchain. On Ethereum, Solidity is compiled to bytecode. On Starknet, Cairo is compiled to Sierra and then to Cairo assembly or Cairo CPU assembly. Smart contracts possess several unique characteristics. They are permissionless. That means anyone can deploy a smart contract on the network within the context of a decentralized blockchain, of course. So, I mean, there are examples of private blockchain, so obviously you need access. Smart contracts are also transparent. The data stored by the smart contract is accessible to anyone. Again, we are talking in terms of the public blockchain. The code that composes the contract can also be transparent, enabling composability. This allows developers to write smart contracts that use other smart contracts. Smart contracts can only access and interact with data from the blockchain they are deployed on. They require third-party softwares called oracles to access external data. Okay. For developers to build smart contracts that can interact with each other, it is required to know what the other contracts look like. Hence, Ethereum developers started to build standards for smart contract developments like ERC, ERC20, ERC721. Okay. Use cases. There are many possible use cases for smart contracts. The only limits are the technical constraints of the blockchain and the creativity of developers. So DeFi, right now the principal use case for smart contracts is similar to that of Ethereum or Bitcoin, which is essentially handling money. In the context of the alternative payment system promised by Bitcoin, smart contracts on Ethereum enable the creation of decentralized financial applications that no longer rely on traditional financial intermediaries. This is what we call DeFi or decentralized finance. DeFi consists of various projects such as lending borrowing platforms like Aave and I would say DYDX or something, decentralized exchanges, on-chain derivatives, stable coins, decentralized hedge funds, insurances, and many more. Tokenization. Smart contracts can facilitate the tokenization of real world assets such as real estate, art, or precious metals. Tokenization divides an asset into digital tokens, which can be easily traded and managed by blockchain platforms. This can increase liquidity, enable fractional ownership, and simplify the buying and the selling process. Voting. Smart contracts can be used to create secure and transparent voting systems. Votes can be recorded on the blockchain, ensuring immutability and transparency. The smart contract can then automatically tally the votes and declare the results, minimizing the potential for fraud or manipulation. Royalties. Smart contracts can automate royalty payments for artists, musicians, and other content creators. When a piece of content is consumed or sold, the smart contract can automatically, calculate and distribute the royalties to the rightful owners, ensuring fair compensation and reducing the need for intermediaries. Again, decentralized identity. Smart contracts can be used to create and manage digital identities, allowing individuals to control their personal information, share it with the third parties securely. The smart contract could verify the authenticity of a user's identity and automatically grant or revoke access to specific services based on the user's credentials. As Ethereum continues to mature, we can expect the use cases and applications of smart contracts to expand further, bringing about exciting new opportunities and reshaping traditional systems for the better. The rise of Starknet and Cairo. Ethereum, being the most widely used and resilient smart contract platform, became a victim of its own success, network congestion ultimately. With the rapid of some previously mentioned use cases, mainly DeFi, the cost of performing transactions became extremely high, rendering the network almost, unusable. Engineers and researchers in the ecosystem began working on solutions to address this scalability issue. A famous trilemma in the blockchain space states that it's impossible to achieve a high level of scalability, decentralization, and security simultaneously. Trade-offs must be made. Ethereum is at that intersection of decentralization and security. Eventually, it was decided that Ethereum's purpose would be to serve as a secure settlement layer, while complex computations could be offloaded to other networks uh, built on top of Ethereum. These are called layer 2s. The two primary types of layer 2s are optimistic rollups and validity rollups. Both approaches involve compressing and batching numerous transactions together, computing the new state and settling the result on Ethereum. The difference lies in the way the result is settled on L1. For optimistic rollups, a new state is considered valid by default, but there is a 7-day window for nodes to identify malicious transactions. In contrast, validity rollups such as Starknet uses cryptography to prove that the new state has been correctly computed. This is the purpose of Starks. This cryptographic technology could permit validity rollups to scale significantly more than optimistic rollups. You can learn more about the Starks from the Starkware's Medium article, which serves as a good primer. Okay. Yeah. Remember Cairo? It is in fact a language developed specifically to work with Starks and make them general purpose. With Cairo, we can write provable code. In the context of Starknet, this allows, proving the correctness of computations from one state to another. Unlike most, if not all, of Starknet's competitors that choose to use the EVM as a base layer, Starknet employs its own VM. This frees developers from the constraints of the EVM, opening up a broader range of possibilities. Coupled with decreased transaction costs, the combination of Starknet and Cairo creates an exciting playground for developers. Native account abstraction enables more complex logic for accounts that we call smart accounts and transaction flows. Emerging use cases include transparent AI and machine learning applications. Finally, blockchain games can be developed entirely on chain. Starknet has been specifically designed to maximize the capabilities of Starks and Stark Proof for optimum scalability. Okay, Cairo programs and Starknet contracts. What is the difference? Starknet contracts are a special superset, superset of Cairo program. So the concept previously learned in this book are still applicable to write smart contracts. As you have already noticed, a Cairo program must always have a main function that serves as an entry point for this program. Starknet contracts are essentially programs that can run on the Starknet OS and as such have access to Starknet's state. For a module to be handled as a contract by the compiler, it must be annotated with a Starknet contract attribute. Okay, so we are going to first of all read this. This is, I guess, a simple storage where we store a single variable. Okay, this chapter will introduce you to the basics of Starknet contracts with an example of basic contract. You will learn how to write a simple contract that stores a single number on the blockchain. Anatomy of a simple Starknet contract. Let's consider the following contract to present the basics of a Starknet contract. It might not be easy to understand it all at once. So what it is doing, first of all, we will come to this Starknet interface later, but to declare a contract, you use the mod keyword and you annotate it with the Starknet contract attribute. Then every contract must have this storage piece. So no matter what is the contract, even if it is a storage is empty, you need this storage struct, and it should be annotated with the storage. After that, we wanted to define this interface. These interfaces are sort of the APIs that we are exposing outside of this contract, people or other addresses, other contracts can interact with this particular contract once it is deployed through this. So we can get a data. We can just get a data, or we can set a data. So that is basically the idea. So let me first write this contract, then we will come back to this. So let me just bring this here. Okay, so let me just close this. Okay. So okay, so maybe it's a good idea to create a new project just to show you how to do this from very scratch. So start new, let's say storage contract. Okay, cd storage. Okay, let's open this then, because you want to do it from very scratch. So we'll just so let's open the terminal here only. Let's open the scarp terminal file, and we need a Starknet dependency because we will use methods that are defined in the Starknet thread, and we want this version to be greater than or equal to 2.2.0. okay, and we also want to define target dot Starknet contract. If I am correct, that is the way of target Starknet contract. Okay, now just do scarp build, and it works fine. Now with the scarp build, we just bring this Starknet thing into this code. Now I'm going to remove everything, and we just do mod simple storage. Okay, and we need to annotate this with the Starknet contract. Okay, and now we need to define a storage. So every contract must have this storage struct, even if the storage is empty. I'm not sure why the formatting is messed up, but yeah, let me. Okay, so we are going to use, let's say, just my data. Okay. Okay, let's just use some unique name. I'll explain you the reason why that is the case. But yeah, let's say awesome data. Let's say store. Let's say the contract name is my lucky number. My lucky number, right? And lucky number, and which is of type, let's say u8. Okay, we are only going to allow number between 1 to 255, right? We don't want like too big. So that is like the very minimal thing. So if I build it, you see it compiles without any issue. So this is like the very minimum thing. Now we are going to define a to interface, like how do we get this data and how do we set this data. So we are going to say trait and okay, I interface my lucky number. Okay, and it is going to take the contract state. We can just use like, you know, very simple word as well, like t. So but it's okay. So fn get in this trait, like as we have seen previous streams, in this trait thing we are not actually doing this implementation, we are just defining method signature. So get method is self and snapshot of the contract state. Okay, and it will return u8 and fn set, which takes ref self mutable self the contract state. And wait, we need x u8 and it won't return anything. Okay, now we are going to we also need to annotate this with Starknet interface. Starknet interface. Okay, let's build this again and we see there is no error. Now we are going to do the implementation of we can first we have to bring this you know, bring this my lucky number into the scope. So we bring this. Now implement my lucky number, implement of, you know, my lucky number and contract state. Okay, we can just copy this entire thing from here and we just need to, you know, okay, and now we just need to define the definition. So for the get, we just do self dot my lucky number, my lucky number dot read. Okay, and if we don't provide the semicolon, it will be the return value, right? It's an expression. And for the set, what we can do is self dot lucky number dot write x. That's pretty much it. Let's try to build this. And okay, so there is some error. Let's see what is the error. Okay, so the error is this t contract state. It should be the word t. So now I think there is still some error. So let's see trait, my lucky number is there. Hmm. Okay. I guess we just need to do T contract state. Okay, it will be contract state. It will also be contract state because this is like something that is available in the prelude. So maybe. So now it compiles fine. So after compilation, what is the next step? So we have seen what is this contract. In this example, storage struct declares a storage variable called store data of type, U128. You can think of it as a single slot in the database that you can query and alter by calling. Okay, then we have okay, the interface, the constructs blueprints. The interface of a contract represents the functions this contract exposes to the outside world. Here the interface exposes two functions, get and set. By leveraging the traits and implementation mechanism from Cairo, we can make sure that the actual implementation of the contract matches its interface. In fact, we will get a compilation error if your contract doesn't conform with the declared interface. In the interface, note the generic type tContract state of the self argument, which is passed by reference to the set function. The self parameter represents the contract state. Seeing the self argument passed to the set tells us that this function might have access to the state of the contract, as it is what gives us access to the contract's storage. The ref modifier implies that self may be modified, meaning that the storage variable of the contract may be modified inside the set function. On the other hand, get takes a snapshot of the tContract state, which immediately tells that it does not modify the state. Public functions are defined in an implementation block. So we have defined the implementation block. Before we explore this further down, let's define some terminology. In the context of Starknet, a public function is a function that is exposed to the outside world. In the example above, get and sled are public functions. A public function can be called by anyone and can be called from outside the contract or from within the contract. In the example above, get and set are the public functions. Okay. What we call an external function is a public function that is invoked through a transaction and that can mutate the state of the contract. That is an external function. Can be called or from within the contract. Okay. So basically the difference between public and external function is external function can only be called from outside the contract. It cannot be called from the inside of the contract. Okay. A view function is a public function that can be called from outside the contract but cannot mutate the state of the contract. Okay. Since the contract interface is defined as the isimple storage trait, in order to match the interface, the external function must be defined in implementation of this trait, which allows us to make sure. However, simply defining the function in the implementation is not enough. This implementation block must be annotated with the external v0 attribute. This attribute exposes the function defined in this implementation to the outside world. Forget to add it and your function will not be callable from the outside. All functions defined in a block marked as consequently be public functions. When writing the implementation to the interface, the generic parameter corresponding to the self argument in the trait must be the contract type. State type is generated by the compiler and gives access to the storage variables defined in the storage struct. Additionally, contract state gives us the ability to emit events. The name contract storage state is not surprising, as it is a representation of a contract state, which is what we think of self in the contract interface trait. Modifying the contract state, as you can notice, all functions that needs to be access the state of a contract are defined under the implementation of a trait that has a tContract state generic parameters. Okay. As you can notice, all functions that needs to access the state of the contracts are defined under the implementation of a trait that has a tContract state generic parameter and takes a self contract state. Okay, and then we just put this. Okay, and this allows us to explicitly pass the self contract state parameter to the function, allowing access to storage variables of the contract. that is like pretty much basic. So now we basically want to deploy this contract, right? So what we are going to do is first we will try to deploy this locally. So I'm going to just run Katana, and it does have these, private keys, public keys, and private keys. So these are basically the accounts that Katana gives. So now we basically just search Katana Starkly GitHub, maybe. Yeah. Okay. Starkly is for running the program. Let's go to here, introduction to Starknet, version, your first not current contract, Starkly. Okay, smart wallet setup. There is some, actually, wait a minute. There is something called so we have already Starkly. I think Starkly is something that we have already got. So we do Starkly - version. So I'm just looking for a way to set this key. Okay. Okay. So wallet setup, use browsers, and okay, the signer is an essential smart contract capable of mkdir, then generate the key store file. Okay, Starkly enables the secure storage of a private key through this encrypted file can be accessed using a password. Wait a minute. So we'll just go to this folder, Starkly wallets cd. We have deployer, and we have, so open Zeppelin account is there. That is our, I guess, main account. That is not key store. No. Okay, so what we have to do is then generate the key store file, the Starkly signer key store. You need to provide the path to the key store file you want to create. Okay, so let's create Starkly signer key store, Starkly signer key store, and from key, and we are also in already in, so my Katana, my local account 1.json. okay, and we paste the private key from here. We are and 1 2 3 4. Okay, so it created a new file, and if we do vim my local account .json, we have some keys there. Okay, so we have the key in the private key, with the private key of your smart wallet. In the password prompt, enter a password of your choice. Okay, now we have the private key. Okay, we have the key, private key. Okay, inside crypto, ciphers, hyperparameters, these are okay. An account descriptor, creating an account descriptor. An account descriptor informs starkly about your smart wallet's unique features such as signing mechanism. You can generate this descriptor unique Starknet fetch account my key store 1.json. Okay. Why do we need this signer? Okay. Starkly account and okay. So let's just account key. So I will just do mb my local account 1.json my local account 1e.json. So that's all I've done, and we will do this thing Starkly account fetch Starkly account fetch, and what do we need is this wallet address, which is the account address. Okay, and hyphen output my local account 1. No valid provider option found following back to using a sequential gateway. Okay, so I think we needed to provide the provider, but it's okay. 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 RPC we can deploy. Okay. Let's go to Katana book. Maybe they have a thing called, so let's see, it's the installation. Okay. This is something different, so maybe we can find something like, Starkly Katana. Maybe they have something for the they don't have that, but anyway, let's come back to, let's run as far as we can run, so I guess I had a couple of commands there, maybe they can help. So these are just the installation commands, these are not the so we can export these commands. Okay, JSON RPC, running a Starknet node. It's okay. No. Starknet ruling. Okay, actually there must be a way of local node for development. Yeah. Got an example how to see voting contract example. Let's see. Mm, okay, Katana is designed. Okay, it will refund the account. Okay, preparing deployer, signer, key store, account description. We can get the public key and the right. So let's see this account descriptor thing. PIM. So the account descriptor is not there. Okay. Touch. Let's just create the okay. Now start the wallets deploy my local account .json. PIM. Okay. Account description will look like this. You can get the public key and the smart class hash. Smart wallet class hash. Okay. Now okay. So public key and wallet address is we have something that we already have, so we can just paste them. Let's paste these. Public key is already there, so and address, account address is also there. Okay, now just close this. Okay, now Starkly class as we declare wallet address, smart wallet address. We need a wallet address and we can do this account address. There must be some activity. So we got the class hash. Okay. In this chapter, we will explore how to interact and deploy account on booking. We will use the voting contract as an example. In the chapter, we will set up in Katana. Okay. You can find the complete on the chapter 3 of the Starknet book. Okay. So we have already prepared the wallet. Okay. For a public key, you can use public key is already there. Is this public key? Yeah, public key is already there. This process is an identical lower account in case you want to have a second and third order. Before deploying, you need to declare a contract. Okay, so we just want to declare a contract. Okay. So this command is sort of big fun, right? But anyway, let's try this. So what we are going to do is run this command. So let's just yeah. So key store deployer slash my local account one key, my local account one key, and my local account one, local account one. Okay, this is good. Compiler version is also good. Target slash tab, and this definitely will be changed. So let's just see. Target dev storage contract, storage contract my lucky number dot sie sierra dot json. Okay, I hope it works. Found config file not found. I was hoping I'll get this up. Okay, let's see. My local account one. Okay, so let's see. Activity less users. My local account underscore one. That's the maybe mb my local account dot json to my local account underscore one dot json. Damn. Now 1 2 3 4. Okay, I guess declaring a contract class, so class hash is finally declared. So we got the class hash. So let's just put this in the readme. Okay, class hash. Okay, so now we want to maybe like export my local account key request to key is equals to this one. We just do export and okay, so now we'll see. We want to basically, so there is no I'm not sure what we are passing here, right? So let's see. Starknet first deployment contract setup declare we have already done, signer and all those things. Key store, account descriptor, account key store. Okay, Starkly declare. It will already run this file. Okay, Starkly deploys, right? if we do this, maybe this, Starkly deploy -rpc -account -keystore. Okay, so let's see do uh, Starkly deploy. Okay, and we will paste this. Okay, -rpc, we'll just copy this for now. Right, 1 2 3 4. Yeah, contract is deployed. You see, we block to mine with one transaction resource uses, and we get all of this thing. Okay, now we want to basically call this. Okay, so you can call this, Starkly deploy, Starkly call, deployed address. The call command is used for invoke command is. Okay, Starkly invoke. Okay, so first of all, let's see whatever the contract is deployed. So deployed contract address. Okay, now we'll do, first of all, I don't like this particular way of doing thing, right? There must be a better way. So we want to physically find out if we can, uh, we can yeah, permanently sort of link these accounts. So I just want to do that first, because this is like a whole new pane. So we have done this, we have done this, we have created the keys, we have done this, we have done this, account descriptor we have created. So let's copy this and put this in a readme. We will not use this readme, we are only way to set account descriptor and keystore path for Starkly, right? So we are going to use this. So let's see. Deployer slash dot JSON. Okay, and Starkly keystore. My local account key.json. Okay, so we have done this. Now let's see what else is there. So let's see, deploying an RPC, choosing an RPC in this tutorial. Okay, set the Starknet RPC. Okay, set Starknet RPC. Not this command. And in our case the RPC is HTTP 0000. Why this? I guess I've done localhost. Why this deploying on 0000? Anyway, let's just do this. So okay, so we have declared the RPC, declaring our contract, so we don't have to now define the contract. So what we are going to do now is we are going to change the contract. Okay, so I just want to check if we can we can yeah, we just want to my lucky number okay, self dot my lucky number okay, and we just do scarf build. And we just do now, so most of the details are there, like starkly declare, okay, target dev slash storage contract my lucky number.sierra.json. So it is not able to take, maybe because I have that shell. Okay, starkly declare an account, my local account as dot starkly college deployer slash my local account 1.json. Okay. So okay, echo, maybe echo dollar Starknet account. It is not coming. That means maybe we will try here, echo dollar Starknet account Okay, it is working here. Maybe like start source. Okay, it is working. Then why it's not working? Okay, let's go there, right? Cairo cd f3 Cairo slash storage contract. Okay, it's works. Starkly declare target dev storage contracts my lucky number sierra.json 1234. Okay, maybe इसका build 1234. Okay, class is already declared, so I want to change something in this file so that you know data u32 and build. So it is not, let's say u32 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 32 and u32. What about now? Okay, maybe it is reading new files. No. Okay. Okay, Starkly deploy. Okay, this. Okay, deployment transaction happen. Starkly call. And we are going to call set. We are going to call, not call, we are going to invoke set, and we are going to invoke this with maybe like 7. Okay, now we are going to see how we are going to call a method, call an interface. Start build, choosing an RPC provider, Starkly declare, deploying a contract, deploy, constructor inputs. Okay, so that's interesting. So let's say get number, set number, get number, and set number. Okay, so we are going to build this again. We are going to declare this again, and we are going to deploy this again, and we are going to Starkly invoke. Invoke set 7 contract error. Set maybe number. Okay.
Flowers bloom with every breath.
What?
Sun and moon, they take a rest. I write your name up in the sky. Hearing your name makes me so high.
Entry point.
Phenomenon.
Error in called contract.
Unexplainable feeling. I was lost, but I found
Starknet felt is not found. Something error is there. So
you don't have to be afraid. Everything will be alright. Stars align for you and I. Maybe we
so
should
this is the issue
both try.
that we can identify, but we are able to deploy the contract, but let's maybe get number, call, there is some issue with this. 232 scarf green. Build. Okay, and
would you let me hold your hand and fly? You don't have to be afraid, everything will be alright. Would you let me hold your hand and fly? Would you let me hold
okay,
your hand?
Starkly call, get number. Entry point not found. Okay, what is this issue? Casting a vote. RPC and everything is already set up. So what is the issue? Okay. 0x1. Maybe like It is not able to give me the number. Okay. Entry point not found. Let's ask the help on Discord. Storage. Right. I get the following. My contract is code is and I'm running one command.
Red skies, the heat of August. It's been a long time, but not enough. 'Cause I'm right back in the palm of your hands, and I don't even understand. All this time, but nothing changes. Why don't we feel like strangers? Thought you had forgotten me. I was finally finding peace. Now we're walking down the same streets. Got your hands in your pockets, like always. Saying everything that I ever wanted on it.
Or PC wireless already set the relevant channel beyond
Red light, you know I'm cautious. Apologize for how you were. Want me right back in the palm of your hands, but I should learn from the past.
appreciate the help.
All this time, but nothing changes.
Appreciate
Why don't we feel like strangers? Thought you had forgotten me.
almost
I was finally finding
an hour.
peace. Now we're walking down the same streets. Got your hands in your pockets, like always.
Patient.
If it was so special, why'd you wait this long to let me know?
Okay, guys,
This
let's
time
take a
nothing
small break.
changes.
I don't want to make this a super long stream, so hopefully I'll figure this issue out in the morning, and we'll cut this. Yeah, thank you, guys.